Hey folks, welcome back to another video in this series on PyTorch. So now that we have seen the autograd mechanism, the tensors, and how to create your networks, different kinds of way of doing it, let's delve into some boring stuff. This is not so glamorous, but then this is a very important part of the deep learning pipeline. How do you load in your data? So in this video, I'll talk about the datasets and data loaders API of PyTorch, and how do you create efficient loaders in PyTorch. Both use the default one and also use custom ones. So whenever you see an example, it's very easy to download dataset because PyTorch or TensorFlow, they have these downloaders that will download MNIST, Fashion MNIST, ImageNet, and whatnot. But in real world, your data would be in a messy format and you will have to load it manually. So that's where things get tricky, and that's where datasets and data loaders come into play. So a dataset just stores basically it stores the samples and their corresponding labels. And data loader is it basically traps an iterable around dataset for easier access. It can shuffle things around. It can load data in a multi-threaded way. So that's the difference. But you need both. So dataset creates, basically stores the samples and whatnot, and data loader loads the data in a shuffled manner or whatever fashion that you want. So I'll link this documentation page in the video below so you can just read more about it. But then this is the meat of the matter or the details of the matter. Datasets can be of two types, map style. Map style basically means I can index into a sample on the dataset like this, and iterable means I cannot. I need to iterate through it. So that's the difference. Um, Today we will work with map style because they are the most common ones. Iterable style, um, well, let's see, stream of data. So that's the kind of example that they belong to. So I'm not gonna use that. So and then this page contains a lot of details. How efficient do you want the batching to be, and how do you want to collate things, and the different single-threaded, multi-threaded business. Um, in my opinion, not so important, but yeah, if you need it, like I think this is the kind of thing that only read if you need. So let's skip all this and let's jump into a simple example that we will use. So instead of downloading any of the data that PyTorch provides, I will download a new data set. Well, I'm not sure if PyTorch has this one or not. Maybe it does, maybe it doesn't. But you might have seen this. This is a pretty old data set, about 8 years now, 8 years old now. Cats versus dogs, and not the movie, but the data set. So yeah, so this I believe it was created by Microsoft for a Kaggle competition. Download the dataset here, and you should be good to go. So once you have the dataset downloaded, extract it out, it will look something like this. The extracted folder would have um, two folders, cats and dogs. Cats would contain a bunch of images of cats, and dogs would contain a bunch of images of dogs. So we will create a dataset out of this. That's typically how you'll see image data in the wild. Um, so we'll work with this. All right, so let me load in um, or open up VS Code. Okay, everything looks good. Everything's lined. Let me jump into the coding part. Okay, great. So first of all, let me write down all the import. So I need to definitely import the data loader and the data set. I think it begins with a capital. That's something that I need to import. I need to import torch. Um, for handling images, I'll use pillow. And what else? For directory handling, I'll use OS. And also from torch vision, I'll import datasets. I'll tell you why I'm doing this. It'll become clear pretty easy soon. And from, well, I'll just import NumPy. Whew, lots of imports. So that's done. Now let me just put the location of my directory. Give me a moment while I copy it. Okay, so that's my data directory. Okay, so that's my data directory. And now I will show you two methods of loading this in. When you have data loaded in this fashion, so what I mean by this fashion is, let's say you have a bunch of images and all the classes have folder associated to them, and the images belonging to that particular class are within it. So here my data, I know like all these are cat images, so they have the label cat, and all these are dog images, they would have label dog. So if when the data is in this fashion, it's very easy to create a data set, and Torch Vision has this utility datasets that does it for you. So let me show you how to create. So let me call it my data one, or let's give it a better name, my dataset one, and then I'll call datasets. I'll pass in the directory, and well, not quite. So I need to tell it that I'm loading an image folder, and then I pass in my data directory. Okay, so that's it, done. Now when I display it, you can see it has already loaded it in. It knows that there are 25,000 images. Pretty good so far. Let's see what all methods does it have. If I do classes, it tells me what all classes are there. So pretty useful, and it's pretty clever. Now, in this data set, all images are not of the same dimension. So we need to convert the dimensions of these images. What I can do, I can iterate over this data set one by one and then convert the images. But then there is a slightly more efficient way of doing it. And that is to specify a transform. So I can specify a transform here, and that will tell datasets that apply this transform to each sample in my dataset. And that's what we will do. There's another reason why we need to, well, put the images to be the same size, is because data loader wouldn't work unless and until all images are of the same size. So that's the main reason. But then there are a few workarounds. Okay, so I need to resize the images. So basically transform, I just need to specify a function that will transform images. Now, TensorFlow being kind provides us these useful functions, and they are present in Torch Vision again, and I'll import transforms here. So let me create my transforms. Oh, okay. I guess it's had my old variable saved. I'll put transforms dot compose. Let me type it out, and then I'll tell you what's happening here. Transforms dot resize, and then I'll resize it to be 224, and then transforms dot to tensor. So here you can see all the list of transforms that I can do. So let's say, well, yeah. So you can apply center crop, jitter, and so on. I just need to specify the function, and it'll do it for me. So you don't need to like write things from scratch, and that's a lot of them. So I want to apply to tensor, and I'll tell you what that is. Why is it not happy? Is it because I haven't specified what the transform I want here? Oh, okay. Why was line 1 not happy? Anyway, okay. So here I specify a transform, and instead of specifying one transform, I specify two transform. So first one is resize. The second one is toTensor. So I'll tell you what toTensor does, but um, since I have two transforms, I compose them. So first resize will be applied, and then toTensor will be applied, and that's my transform. And this is what I specify when I load in my datasets. So that's all there is. Now, what toTensor does is when we load in the data, the data is loaded in PIL format. So I need to convert it into NumPy array or PyTorch tensors. And so this is the reason why I call the toTensor method. Um, let's see. Let's take a look at the methods that Torch Vision dataset has. Let's see. Okay, so you can so basically root specifies the root directory, transforms is what we said, and yeah, okay, that's pretty much it. So far so good. I mean, we made the maximum utilization of what we had. Okay, now when I query, well, let me create my data set, and then now when I query, you can see the transform that will be applied to each image. Good. So with the dataset object in hand, we can create a data loader object. So let me call it data loader 1. Let me call it data loader 1, and then I'll create a data loader object. For a data loader object, you need to specify your dataset. Then I specify the batch dimension. So dataset is 1. I think batch. Why is it not? Oh, should have widened. Oh, okay. I specify that to be 10, and then I specify that it should be shuffled. So this function takes care of everything. It will batch my data, and then it will shuffle it. Oh, shuffle should be true. Shuffle my data. That's my data loader. Module is not callable. That's is it capital D? Did I mess it up? No, that's small d. Wait a minute. Is it data set and data loader? Actually, let me just double check. I think both should be capitalized. Data. Oh, come on. This is. Whew, I need to get my convention straight. I keep messing up things. I keep messing up simple things. So it should be data loader with a capital L. Okay, right. Everything was fine and I just messed it up. Okay, I have my data set, and then I have my loader, and then loader has an L capital, so okay, everything's kosher now. Good. Now, data loader isn't it. You can create an iterable object out of it, and here you can see it has a bunch of complicated functions or complicated name value pair, batch sampler, how many workers you want for multi-threaded environments, do you want to pin memory or not, and so on. So I'll just keep it simple and I'll show you what how does it look like when I load in a data. So first I create an iterable out of it, and then for iterables you always call the next function to get a bunch of data, and this should give me about 10 data points, and I just want to view the labels. So when I run it, you can see I get some cats and dogs. So it's PyTorch has put it in 0 and 1 format. And you can see it's shuffled because we didn't get all ones or all zeros. So this is a very simple way of loading in data by just specifying the folder where your data is kept. This works very well for images, particularly. And then create a data loader, and data loader object is what you will use in your training loop. Okay, so that was for images. Now, what if you have images in a complicated fashion, jumbled up, or any other data set that's complicated? There must be like similar dataset methods for like other formats like text as well, but we will not look into that. We will see how to create a custom dataset. So to create a custom dataset, you need to subclass from the dataset class, which is in torch utils.data. And subclass means it's a class. So let me create our own dataset. So my dataset, and then this is okay. So there are three very important methods that you need to define that your dataset needs to have. It needs to have the constructor. I don't like that. So in the constructor, I will take in, let's say, my data path. So path. Here I will specify. Okay. So this is what I'm going to do. First, I'll get the list of all the dog images. So I get, let me call it dog list. I like the D smaller. And then I will call the list directory method, and then it's path plus, because I know dogs and classes have their separate path. So that's my dog list. And the same thing for cat. So these two variables will basically have list of all file names contained in these two respective directories. I define my the label to be none right now. What else do I need? And let me just save the path. So that's my constructor. Now, the other method I need is the length object, because I need to be able to query the length of my dataset. So this should just return the number of dog images plus the number of cat images. That's it. And then we need our dataset to be addressable. So we are making a map-based dataset. So I need to be able to access elements or access the next element and so on. So I need to define the getItem method. And getItem method takes in, I wonder where all this autofill is coming from, but which plugin? I have tons of plugins installed. I don't know which plugin is causing this. So for getItem method takes in one variable, which is the index. So whenever you address into a list with square brackets or any other object, the getItem method is called in Python. So let me bring this up. Okay, so right now I want my data set to be sequentially listed. So what I mean by that, like the first however many indexes should correspond to dogs, and then anything beyond that should be cats. So let me do this. If index is less than the length of my dog list, then I set my label to be 1, and let me grab the image. So I will grab the image by using pill, and pill on which file? So on my directory, and then I need to go to the dog folder, and then I will access the file. So in dog list, I will access index. Okay, so what this does is whenever the index is less than the length of the dog list, find the image, in the corresponding location, load it up, set the label to be 1. Let me just copy this for easier. Else, it's a cat class, so I set the label to be 0. Hang on, let me just, it is not how I want it to be. Wait, VS Code screen has become too big for its own good. Let me just, okay. I hope you can still see it. Okay. Right, so yeah, so now I'll probe in, for the else case, I'll probe into the cat directory and get the cat image out. Finally, I need to convert the image into a NumPy array. Here you can always do the data type conversion if you want to do, or any transforms that you want to apply, or any of that jazz. And then I am also going to resize it. I'll just use NumPy's resize image, and I think I need to provide in the dimensions. I don't know if it does it in place, but doesn't matter. And then finally, I return two things. I return the image and I return the label. So that's my data set. Again, let me recap. You need three methods to create your own data set when you subclass it from dataset: the constructor, the length method, and the getItem method. So length method so constructor can take in like whatever you want to give it. I passed in path. I generate the list of dog images, generate the list of cat images. Length object returns the sum of the two images, or sum of the number of images. And then getItem returns back the label and the image associated to it in a sequential fashion. Because so first, however many sequences are dogs, and then cats come. All right. So I had to pause the video because I was getting a call. Now I'm back. Okay, what we've done is our loader is ready, our custom loader at that. And now let's create an instance of it. So let me call it cats vdog. And then I will call my dataset with the path. What was the name of the variable? It was data error. Okay. And it's done. Now let me construct a data loader with this. Now we do not need to specify the transforms because I have taken care, or I didn't specify the transforms because I had taken care of, I can specify transforms here, but then since I'm already taking care of the resizing and the image dimensions inside, or rather the tensor conversion inside, I don't need to worry about that. I'll do the same, bat size to be 10 and shuffle to be true. My data loader is ready. Now I will try to read in some elements and see the output. And I encounter an error. List index out of range. Oh, I see. Okay, so let's say there are 1,000 dog images and 1,000 cat images. I see what's the issue. So my total index should go from 0 to 2,000, right? No, 0 to 1999. Now, as soon as it crosses 1,000, it knows it's not a dog anymore. It goes here and tries to, oh, first of all, I have to fix this. It tries to go into the cat list and tries to figure out what's the location at index, 1,000 plus, like say 1,200. But then that doesn't exist. So we need to take care of the offset. So index minus length of the dog. And this will take care of things. Let me run the iterator, and then boom, we were able to load in the labels. So here we go. We created a custom data set, and this gives you a lot of freedom. You can do load in different kinds of data, pre-process them, and do all sorts of things, and then package them inside the data loader to just read it like a regular data set. So PyTorch gives you a lot of freedom in the way you want to handle data. And data loader has some advanced option, but just use them only when you need them, or just read them when you need. So I think this covers the data loading aspects of things. I know this was kind of boring and not the most glamorous bit, but then this is still important. All right, I'll wrap up this video with this. And again, the code is in my GitHub page. Please like and subscribe. And if you're interested in some Halide stuff, check out my Halide series that's ongoing. And also check out the other videos that I've been making. All right, see you guys next time. Bye.